What's up, Wildcats? Mr. C coming at you with another video. Here we go, starting a new unit, but before we do, I want to introduce you to my friend. This is the Cheat. He's my little plush doll that I've had since I was, 12 years old, probably earlier than that. But he's from one of my favorite websites of all time. And let me tell you why it's my favorite website of all time, or one of them. Well, it's funny, and it's clean. What's better than funny, clean humor? Absolutely nothing. Very good. Answer correctly. Homestarter.com. Your parents would approve. It is clean. It is funny. Go to it. Meet the Cheat. All is well and good. But we need to learn about work. What's work? Well, let's talk about it. What is work? All right. We got this rock climber here. Is that work? Heck yeah, it is. I'm not climbing a wall. This guy's not even strapped in. He's so boss. Look at that. He's just like, oh, I'm going. All right. Well, that's work. But in physics, there's an actual definition for work. Work is done when a force, okay, well, we've talked about forces. A force is a push or pull on an object. Work is done when a force acts on an object in the same direction that the object moves. This is key. All right, a force acts on an object in the same direction that the object moves. Let's take a look at what that looks like. One of the best episodes of all time, if not my favorite, because you got the Alaskan bullworm. But what's the point? Well, you just saw the whole town push Bikini Bottom. Well, let's take a look. What direction is the town moving? Well, from the video, the town was moving, yes, very good, to the right. Very good. And, well, what direction is the force pushing it? Well, they were pushing to the right, right? Yeah. So, wait a minute. If they're pushing to the right and it's moving to the right, isn't that work because it's in the same direction? Yes, it is. Very good. The town is moving right and the force is pushing to the right, so there is work being done. Remember, work is only done when the force applied to an object, here it's the whole town, is it moving, is the same direction as the town is moving, okay, or the object is moving. So in this instance, since the motion lines up with the force direction, all right, that is work being done. So let's take a look at an example where they're not the same. What direction is the pizza moving? Well, based on this GIF, not GIF, based on this GIF, all right, the pizza's moving to the left. All right, we see that? Yeah, it's moving to the left, right? Well, what direction is the force holding it? All right, well, this is different because is SpongeBob pushing it? No, he's holding it. He's carrying it. Well, what forces are acting on the pizza? Well, we know gravity is, because gravity acts on everything. Gravity is pushing what direction? Gravity's pushing down, all right? Well, what direction is SpongeBob applying to? What's the direction of the force SpongeBob's applying to it? Is it left? Well, no. He's not applying anything left. He's holding it. So if you're holding it, if you're keeping it from dropping, what direction must the force be applied? Yeah, it's up. It's up because gravity's pushing down. If you're holding something, you're holding it up. You're keeping it from falling. So the force direction is up in this case because he's holding it. He's carrying it. He's not pushing it along. He's carrying it. So therefore, does the force direction match the direction that it's moving? It doesn't, because up and left are not the same direction. The pizza's moving left, but the force carrying it is pointing up, so there is no work being done. You see that? They do not line up. So anytime you carry something, and you're not moving it up and down, then there's not technically being work done from a physicist standpoint. All right, let's take a look at another situation. The OG episode, one of the first, the Rip Pants episode, such a classic. But what do we notice about that? SpongeBob could not lift the dumbbell of marshmallows. There's no movement. Remember, work requires a force and a distance. Was there any distance? Did it move at all? It didn't. So if there is no movement, then there is no work being done. He couldn't lift it. Even though it looks like he's straining, it looks like he's doing a lot of work. By a physicist standpoint, in physics, we say he's not doing work because, well, although he's applying a force, it's not moving. Therefore, it's not work. All right? So we can quantitatively talk about what work is. Now remember, work is force and distance, but if we want to find an actual number, if we want to compare work, we can calculate it. We can calculate it by multiplying force and distance. Now, remember, force is measured in newtons. Distance is measured in meters. These are the SI units. These are the standard units we measure force and distance in. So if we're multiplying them, if we're multiplying force and distance, we would get Newton meters, newtons times meters. Well, we call that something. We don't like to say Newton meters. We want something shorter. So we call that a joule, all right? So that's called a joule. A joule is equivalent to a Newton meter. So we just shorten it with the name. Now, let's take a look at an example. Amy uses 20 newtons of force to push a lawnmower 10 meters. How much work does she do? Well, work equals force times distance, right? Work equals the force, which is 20 newtons, times the distance that it traveled. The lawnmower traveled 10 meters. So 20 times 10, that's 200, right? 20 times 10, that's 200. And what's the unit for work? Well, we just said a Newton meter, which is what we get here, is a joule. So it's 200 joules of work. One way you can think about it is like, okay, it's asking me how much work does she do? Well, I know it's going to be in joules because it's asking me about work. Work is always measured in joules. So that's an example. Gertrude, I don't know if you know any Gertrudes. If you do, I'm sorry. But when I think of a Gertrude, I think of like an old woman, moving a vacuum or something. Uses 100 joules of work to push her vacuum 50 meters. All right, that's a long way for Gertrude. How much force did she apply? Well, now we're trying to find force. So we know our answer is going to be in newtons. Well, if we rearrange that equation that we had, force is work divided by distance. Well, what's our work in this example? Well, Gertrude uses 100 joules of work. Okay, so my work is 100 joules. I know that because it just said that. I also know it because the units are joules. So 100 joules divided by distance. What distance did she take the vacuum? Well, she pushed it 50 meters. So what's 100 divided by 50? Well, that's 2. That's 2, and it's 2 newtons because we're asked how much force did she apply. Force is measured in newtons, which is abbreviated with an N. So just plugging into this equation, we got 100 divided by 50 is 2, and we know that it is measured in newtons because we're trying to find the force. All right, and I will give you these equations on a test, but with simple algebra, you can figure out, from the very first equation we had, work equals force times distance, that force equals work divided by distance. All right, one last example. Olga, from Hey Arnold, if any of you know the old Nickelodeon TV shows. Olga uses 100 joules of work when pulling her pail of water up from the well. If she pulled with 2 newtons of force, how deep was the well? Well, okay, what's it asking us to find? How deep was the well? How deep something is, that's a measure of distance. That's a measure of length. So we're trying to find the distance here, okay? We're given work. We're given force. So we need an equation now. Well, we can rearrange the equation again to solve for distance. So distance is work divided by force. What's our work in this example? 100 joules, because it says uses 100 joules of work. We also know that because joules is a measure of work. Pulling her pail of water up from the well, if she pulled with 2 newtons of force, well, that's our force, 2 newtons. Okay? So work, 100 divided by force, 2. 100 divided by 2, well, that's 50, right? 50. And we're asked to find distance, so that's 50 meters. Okay? So in all these word problems, what you're asked to do is, okay, what's my distance, what's my work, what's my force? And whichever one you don't have, that's the one you're solving for. And just check, do my units make sense for what I was asked to find? And that's it. That's work.